Okay, are you ready to pay attention, everyone? I have only 1, 2, 3, 4, 5, 6, 7, 8 students. Wow, this is a student que need to pass this class, no? Daniela Rabasa, Fidi Edward, Luis Cifuente, Carlos Duque, Daniel Giraldo, Leonardo Aguilar, Ana Cruz, and I don't see very well your name, Shayir. Okay, look at that. Remember the last class we studied the three vectors, no? Tangent, unitangent vector, uninormal vector, and binormal vector. So to illustrate this idea, I have this airplane, no? So in blue color, do you see this arrow? This is the unitangent vector, I suppose, no? And the unitangent vector, remember that this airplane fly throughout the curve in 3D. So this unitangent vector point to the nose of the airplane can indicate the velocity, no? So suppose that you have a motion that is completely rectilinear, completely rectilinear, no turn to the left or to the right. Entonces we have only the blue vector and the other vector no. Bueno, okay. Ahora suppose que the trajectory is planar, so in the same plane. But you moving to the left or to the right. In this case, to the right. This is my right hand side, or to the left. So we have normal. So the red color indicate the uninormal vector. Okay, entonces this, you know, the interpretation is when you turn. Entonces the univector you suppose that we have in the wings of the airplane, no? And binomial is a little bit complicated to understand. It's in the tail. Look, in the tail of the airplane here, you see the binomial, binormal vector, B. Entonces, when you change the plane of the motion of basic, when you twist like that, look, this is the you twist like that. You twist, not necessarily turn, no twist. Is the interpretation of the binomial vector. More clear or confusing? Clear or confusing? Come on. Today we practice. Clear. Okay. Today, of course, we play the game of the Frenet-Serret formulas. And to compute the something, curvature, torsion. Okay, one more thing. What is curvature? Curvature is the, you know, give me somehow the measure of the when the curve follows the straight line. So you are doing smooth. Oh no, the curvature is low value. However, if you are doing too fast, entonces the curvature is high. Okay, and associated with the curvature, we have the ocular circle. Okay, ocular circle is a circle that has the same point of the curve. We have a curve. Where we select one point in which I want to find the curvature, and associated with this, I draw a circle. A circle share the same point with the curve and share the same normal vector and tangent vector. It's the same. But what is the reason? Can you using circle? Because circle is a specific curve in which the curvature is constant. The same curvature for any point of the circle. By the way, the radio of the circle is the radio of curvature, que es the reciprocal of the curvature. Curvature es el parámetro, suppose 2. 20. Now, the reciprocal, 1/2, 1/2, is the radio of curvature. And the letter we use to represent this is rho. Entonces, let me refresh your memory. Let me refresh your memory. And I have ¿cómo es? The GeoGebra. Okay. I showed you last time, but I want to repeat again. Okay, we solved that problem in detail now using the Frenet red formulas. Okay, in this case we have elixir. The parameterization of this elixir is, look, sine. Remember, the parameterization is completely optional. Well, no, they are rule, but well, okay. In the elixir case, I suppose that the first component is sine and the second component is y, is 2 cosine. That is the reason that different 1 and 2 is elixir. In this case, you see one point is moving using a slide and animation. Then you see when the point is moving, the blue vector that I show you here is the tangent vector. It's obvious it's tangent, right? It's tangency to the curve. And the specific point A, we can see the ocular circle. And you see how increasing or decreasing the radius, no? And you see in the left and the right part of the curve, this blue curve, this blue is the curvature equation. So you see, for example, in the point t equals 0, is this point. Bang. Okay, this point. Let me stop. Let me try to stop the slider and put in t equals 0 here. T equals 0. Oh, no, actually, it's not. Well, okay. T equals 0, little bit. T equals 0. At t equals 0, you see that the ocular circle is small. That means that the radius of curvature is small, but the curvature is big, is maximum. However, in pi over 2, is this point approximately. Let me try to find it. I don't know exactly, but I got it. Pi over 2. You put it here, type it, pi over 2. No, it's okay. Pi over 2 is here. Okay, let me try by hand. You move in the slider. Carajo. Okay, pi over 2. Well, pi over 2 is not exactly here, but approximately here. The ocular circle is big, so the radius of curvature is big. However, the curvature, que es reciprocal, is minimum. Do you see that or no? Do you see that or no? Yes. Okay. Super. Now. Let's move on to whiteboard. In the whiteboard, we solve that problem, specific that problem. Switching to whiteboard. Do you see the whiteboard? Okay. Do you see the whiteboard? Okay. Now. What are you doing? This example 1. Example 1 is elixir. Entonces I'm doing the parameterization for the elixir. The parameterization is the position vector at any time. Suppose there are many ways, guys. Is sine t, comma 2 cosine t. So you suppose cosine first and sine second. The only thing that change is the orientation for the curve. The orientation. Pero it's okay. You know, si you divide by 2 and you adding sine squared plus cosine squared equal 1, to say this is the equation for this. Okay. Now remember the formula for the curvature. The formula for the curvature, kappa, curvature, is the magnitude of the r prime across r double prime divided by magnitude of the r prime raised to the cubic power. This is a general formula. However, I want to prove one particular. in 2 dimensions, because this problem is 2D. So today I bring 2 examples 2D, and after one more example 3D, but it's the same. It's the same. Now, my recommendation is when you face that problem, the first thing you should do is find the first derivative of the vector value function, derivative sine cosine, and derivative cosine is minus 2 sine t. Stop now. You find the second derivative, because the formula involves somehow the second derivative is minus sine t, comma, minus 2 cosine t. Okay, super. So far it's easy. You can, yeah, you can. However, I I want to prove one particular formula in 2D. It's super easy. Look. In order to find r prime across r double prime, you know, we apply the famous determinant, no? Cross product. Entonces, I suppose here in between r prime and r double prime, because the component is x prime, y prime, and our problem is 2 dimension. So the third component is 0. However, inside the definition of the cross product is 3 dimensions. So you suppose k is 0. Okay, and here we have x double prime. Always in general for any problem. The formula I want to prove now is general for any problem. It's 0. And when you compute that, it's obvious that the only component that exists is the k component. Because the minor, okay, the minor, when you have the minor and one entire column is 0, es 0. Entonces, I es 0, y es 0, pero k no. Entonces, k es x prime, y prime, x double prime, y double prime. Entonces, the formula es k. La multiplication is x prime times y double prime minus x double prime y only one prime. And this is the formula. Entonces, the kappa in 2D, the formula is, well, actually es absolute value. Entonces, si you compute the absolute value, that part k disappear, no? No Victoria anymore. And the formula is x prime minus y minus no time, coño. Time y double prime minus x double prime y prime in the top, of course, absolute value divided by absolute value this case. Well, this is okay, this is x prime, this is y prime, this is x double prime, and this is y double prime. Entonces the velocity, que es this, is x prime square plus y prime square, and square root this, no? Pero in the formula for the curvature, we have cubic. So actually, we can condensing like a 3/2. Wow, this formula is easy. I like this formula for solving any problem in 2D. And this is the formula that you use in the homework number 4. Okay, let's do it quickly. Okay, look at that. In my specific problem, the top part of the formula is x prime. X prime is cosine t, multiplication by y double prime. Okay, it's minus 2 cosine. Okay, look, double prime is this, ¿qué es this? X prime is this. Plus or minus, I don't know, es minus, no? Es minus what? Bueno, es minus x double prime, que es minus sine. Multiplication by y prime, que is minus 2. Minus 2 sine square. So basically is minus 2 cosine square t. We have 3 minus also, minus. It's minus, wait. Sometimes we are here. It's minus, it's minus, it's minus, it's minus. What? I don't know. Minus 2 sine t. 2 sine square t. Okay. So basically, you factor out 2. Something is weird. A ver, es x prime, es cosine. Y double prime es minus. This is x double prime is minus. And y prime is minus. Okay. Okay, entonces we have actual value this. Que in this case is 2, no? In this case, 2. It's 2. Okay, something is weird. Carajo. Wait. I make a mistake here, maybe, no? Derivative sine is cosine. Derivative cosine is minus sine. Well. Okay, some sign I lost. But in my paper, I get, not this. I get this. Minus 2 cosine square t plus 2 sine square t. So the answer is 2 parentheses sine square t minus cosine t. I didn't calculate, no? I don't know exactly what happened here. Entonces de kappa, que es the curvature, is the actual value of this. Minus cosine square t divided by, divided by something, divided by cosine square t plus 4 sine square t. Because it's y prime, and x prime is cosine square, and the square, this is 4 sine square. And everything raised to the 3/2. Okay, this is the formula, the general formula for the curvature for the elixir. However, I want to find the curvature at t equals 0. So curvature at 0. Well, curvature at 0, you evaluate sine 0 is 0, is 1, and this is okay. Curvature is equal. I got lost here there when you remove everything become. Wow. I don't know. I make a mistake in one part. I make a mistake, but I don't see now. I don't see now. Okay. Let's do it again. Let me try. Okay. Let's using our. Don't be nervous. Let's try. Okay. Help me to understand this. The derivative is okay for you or no? Bang. We did okay or no? Okay. Now, x prime is cosine. Y double prime is minus 2 cosine. Minus. The formula have a minus here. X double prime is minus sine. Multiplication by y double prime. Oh, y prime. Y prime is sine also, minus 2 sine t. Okay, this is x prime. Let me check it. This is y double prime. This is x double prime. And this is y prime. Okay, so we have minus. It's exactly the same answer. minus 2 cosine square t. And this is the 3 negative is negative. Negative 2 sine square t. Okay. And this is, you factor out my minus 2 outside. We have cosine square t plus cosine square t is 1, no? However, if you find the absolute value of this, the answer is 2. So the top part of the formula is 2. Wow. I don't find this in my paper. Okay, no problem. Now the formula for the curvature to any time could be when they wrote the original equation into parameter. No, it's okay. It's okay. It's exactly the same I copied in the algebra. Okay, entonces es 2 over something. 2 over something, and the bottom is clear. The bottom is cosine square t plus 4 sine square t raised to the 3/2. So the bottom is classical, no conflict. Now at t equals 0, the curvature at 0 is, look, evaluating 0 is 1, is 2. Okay, I get the same answer. Okay, cosine 0 is 1, sine 0 is 0. Entonces, curvature is 2. And the radio of curvature, que es rho, es the reciprocal, es 1/2. It's 1/2. Now, let me see our ellipse look like that. Look, xy. Our ellipse look like that. No? Okay, this point is 2, and this point is 1, no? So our ellipse, okay, A is 1, and B is 2, no? So this is the major axis, this is the minor axis. Entonces at t equals 0, okay, at t equals 0, the position of the vector position at 0 is 0,2, no? It's exactly here. At t equals 0, we are here. T equals 0. Suppose now, okay, I want to find the osculated circle. Osculated circle, in my opinion, look like that. Look, right? Osculated circle. The radius of this is 1/2. Therefore, the center of this osculated circle is located approximately here. And the formula to find the center of the osculated circle is the point, our point in this case is 0,2, plus something, plus the radius of curvature, que es 1/2, and multiplication by the normal vector. A normal vector is a vector, you know, que points in that direction. A normal vector is obvious. Look at my imagination. I can't compute it using the formula. It's too long if you want. The normal vector is the vector que point down. The normal vector is 0, -1, no? O sea, básica es minus j. Es minus j. Because the normal vector, so this is the tangent vector, unit tangent vector. The normal vector is pointing in that direction. But of course, it's small because it's -1. This time is 1. And rho is 1/2. Therefore, the center, in my opinion, using my common sense, is located at the point, center is located at the point 0,1.5. Because remember, the point is in 2, no? The point is in 2. And the radius is 1/2. And the normal vector, okay, normal vector, using my intuition, no mathematics, the normal vector is, we can do by hand if you want, but no, it's too long process. Okay, entonces my equation for the osculated circle is x squared plus parenthesis y minus 1.5 squared equal radius squared 1/2 squared 1/4. This is the formula for the osculator circle. Do you see or no? Fantastic. Okay. Okay. This was confusing problem, but don't worry. I try another more clear problem. Likewise, we can do in any point. In this case, okay. Let's do another more clear example. A power 2. But I am not sure that my equation of the curvature. Suppose, well, okay, let's do it. A power 2. Suppose that t equal power 2. T equal power 2. We find the curvature at power 2. It's 2 over something. This is 0. This is 0. Cosine power 2 is 0. Sine power 2 is 1. Entonces you have 4 raised to the 3/2, no? Que basically is 3/2 is the square root 4 is 2, and 2 raised to the cubic power is 8. So actually is 2 over 8, no? It's 1 over 4. 1 over 4. This is the curvature. And the radius of curvature, rho, is the reciprocal of the curvature, que 4. Wow, that is the reason that this is the big. A ver, Professor, why 1 over 4? 2, is, let me see, is 2 divided by is square root 4 raised to the cubic power, no? Square root 4 is 2, and 2 to the cubic power is, the original equation have y over 4. Yeah, of course, but in the parametric, hello. The original equation, guy, I suppose, I omit the explanation because I suppose that you know that. Okay. This is the original equation. However, you consider like that. Look, x over 1 squared plus y over 2 squared equal 1, no? And this is cosine t, or sine t, I call. Sorry. And this is cosine. Because I know the famous trigonometric equation is sine squared plus cosine squared equal 1. Therefore, my parameterization was, at the beginning, I skipped that part because I suppose that you know. X equal sine t. And y is equal y over 2 is 2 cosine t. That is the reason I write this automatically. This is clear or no? Okay, Annette. So, Annette, you discover our circle, the radius 4, and the center is located at the point Restrepo. What happened with Restrepo? Would your answer be the same if you the answer is yes. Yes. The only thing is change. You change cosine is the orientation. Okay, remember. This is a classical question. The parameter is not unique. I define one way. You define in different way, but it's the same curve. But what is the only difference? The orientation. So how the curve travel. The orientation. So the orientation, remember, orientation is something like that. Orientation. This is the t equals 0 point. And this is the t equal pi over 2 point. And the orientation is in that direction. So you put cosine first and the y and the x and sine, the orientation change like that. But it's the same curve. Clear, Gerardo? Answer me. Guy, I suppose que you know that, coño. Okay. Entonces, let me finish with that idea. I have in my hand the radio of the osculated circle. I need the center. But the center is located here, look. And this distance for the point, let me try to find why I don't understand, Professor, is why the equation is one quarter is 4. I don't understand the question. Repeat the question again. Activate the microphone. Well, today is a bad day. What is the problem? The osculated circle equation. Oh, okay. The osculated circle equation. This one, Gerardo. This equation or the new one? Okay. The center here is at the point 0, 1.5. Do you understand this or no? Look at that. It's the center. And the radio is 1/2. And entonces I know the fórmula que x minus h squared plus y minus k squared equal r squared, no? Ya habla de fórmula. End the story. R is 1/2. 1/2 is square 1/4. I don't understand what is the problem. Okay, I got it. Okay. Sorry. Wow. Let me try. Guys, this is the advanced class. Okay. This is the center. The center is 4 unit here. 4 unit. Okay, this is 4. Therefore, it's -3. The center is located -3. At the point -3,0, no? Is located. And the radius of the equation for the unit circle is, let me see my paper, is x plus 3 square plus y square equal 16. Boom. This is the equation for the osculated circle and the position disk. By the way, I forgot, for example, the position vector. Look, okay, I determined here, but using intuition, the position vector in pi over 2 is at the point 0,1, no? Because cosine pi over 2 is 0, and cosine pi over 2 is 0, it's 1,0, sorry, 1,0. Sine pi over 2, sine pi over 2 is 1, and cosine pi over 2 is 0. This is the position. How do you get the center? The center is, look. I know. Okay, guy, focus. Coño, focus. Look, I discovered que the position vector at pi over 2 is 1,0. Yes or no? How do you find that? Look. How do you find that? 1,0. Plug it in. Plug it in where? In the position vector of the original, no? Sine pi over 2 is 1, and cosine pi over 2 is 0. And this point is obvious at this point. However, in the curvature, I determined the radius of curvature is 4. This is 4 distant in that direction. ¿Make sense? Entonces, well, 1 minus 4 is -3. At the center, I discovered that the center is located at the point -3,0. Clear or no? Okay. Wow. It was hard to you understand this. Okay. Let me come back again to this is exactly the answer I have in my paper. The mistake I make in my paper was, so when I solve it here in front of you, I get the right answer. So the formula, this formula is correct. In my paper, I put it wrong. The top is 2. Okay. 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 Let me try to. Okay, this example was not good. Let me try to come back again to the algebra to show you something. Look. Okay, here. Okay. There you go. Look. Okay. Do you see algebra? Okay, look. Do you see? Okay, good. Look, let me show you. Okay. Okay, look. Okay. Suppose now I want to change a little bit. I change the parametric equation. Look, let me show you. I put no 2 cosine. I put here, guys, we can use in this script when you are doing the homework number 4 to verification. I put here sine and cosine, but you can edit this script. This script I sent to you in the email. Yes or no? This is yours. This is your super fantastic calculator to compute curvature. Okay? Just you change to sine. What's going on? Wow. Wait. Okay. Okay, 2. Enter. Let me put here 2. Enter. What's going on? Well, everything is wrong today. It's a question. I don't know. I can show you something, but I cannot. Okay, this is, let me see. 1. The original one. Something is wrong in this equation. Maybe I delete something not intentionally. Carajo. Okay. No. You don't save this. And open again. Don't save. Open again. Let me see. Open. Curvature. Okay, there you go. Do you see now? Okay, good. The thing I try to do is, I don't know what's going on. Something I screw up something. Okay, suppose I delete these 2. Press enter. Bam. It's a perfect circle, sine cosine, right? And you see the curvature is constant and the circle, it makes sense, right? And the osculated circle, I don't know, disappear the osculated circle. No, it's a coincidence. The osculated circle is a coincidence with the original curve. Okay, and the curvature is constant. Make sense or no? So in this second problem, in this second example, I want to prove that. Let's come back to the whiteboard. Okay, and the second example 2. Do you see the whiteboard or no? No. Okay. Let me try. Carajo, no. Okay. And example 2, I want to using this equation, x squared plus y squared equal a squared. And a is a radius. This is a circle, right? Circle, the center is located at the point 0,0, and the radius is a. Radius is equal a. And the parameterization of this curve maybe is something like that. You define cosine t and you define sine t. Pero A, que es el radio. A, que es el radio. This idea is clear, yes or no? Because maybe I'm doing too fast, no? This idea is clear or no? It's clear or no? Okay, I explain in detail. What mean the M. Annette, I explained the last class, parameterization. Okay. You take advantage, you define que x is equal a cosine t and y is equal a sine t. When you square, and you adding these, es equal a square como factor, cosine square t plus sine square t, que you know is 1. And we come back again to the beginning. So this, entonces, bueno, okay. Entonces you can put sine here. Perfect. But I explained last class. Okay. The thing fly in the air. Well, professor, you put sine here and you put cosine here. You can, of course you can. What is the only difference que change? It's the same curve, but maybe change the orientation. When it's cosine, rotate counterclockwise, and when it's sine, rotate clockwise, like in the previous one. This is clear, Gerardo? Everything okay or no? Okay, let me try to using the Frenet Serret formulas to compute everything. Curvature. Okay, carajo. What? Okay, you find the derivative, first derivative. The first derivative here of the position vector. First derivative. Okay, by the way, guys, the first derivative is the velocity, no? This is the velocity vector. Entonces deriva de cosine sine. Entonces es minus a sine t, coma a cosine. Deriva de sine cosine. Super. Suppose now, okay, want to find the second derivative. Okay, by the way, this is acceleration. You can call it either way, second derivative or acceleration. Everyone understands this. Now, this is minus a cosine. The derivative sine cosine, but with this minus t. And derivative cosine is minus sine. Entonces minus a sine t. Entonces en my formula, this is like x prime. This is y prime, this is x double prime, and this is y double prime. Entonces, when you apply the formula of the curvature, remember the formula, say, is x prime multiplication y double prime, no? Minus x double prime, y prime, divided by x prime square plus y prime square, everything raised to the 3/2. This is the formula for the curvature. Okay, in our specific example, x prime is this. Is minus sine a sine t. Sorry, a sine t. Multiplication by y double prime. Y double prime is this. No, es this, sorry. Entonces minus a sine t minus x double prime, que es this, que es minus a cosine t, multiplication by y prime, and y prime is positive a cosine t, divided by x prime. X prime is prime square. X prime square is minus a sine t square plus y prime square, que es a cosine t, square, and everything raised to the 3/2. Okay? Entonces we have here, this and this together is a sine square t. And this together is double minus become positive a square cosine t. Therefore, CU factorization is a times a square outside, and sine square plus cosine square is 1. And the top we have only a square. In the bottom, we have similar situation. We have this and this together is square positive, to say a square, only a square. When you find the square root, is a, and raised to the cubic power is a. In the top we have a square, in the bottom we have a cubic. So 1 over a. And this is a curvature. And this is expecting, because the radius of curvature gets a reciprocal is a. So in the circle motion, the circle motion, it's obvious that the curvature is equal the reciprocal of the radius, and the radius curvature is a radius. Make this is clear, this example, or not? No? Clear. Okay. Let's move on to the parabola. Another example to parabola. Parabola. Or another example 2D. We're using the same formula. 2 dimension. Example 3. Example 3. Example 3 is, suppose the equation y equal x squared. It's a parabola. The basic parabola. Not sophisticated. Basic parabola. Open up. xy. If I want to find, for example, in this point 0 at t equals 0,0, I want to find the curvature and the equation for the osculated circle. Okay, two things. I need to find kappa at 0. Then I need to find the equation of the osculated circle. Well, first of all, parameterization. The parameterization is too easy. Using the intuition is, I declare, for example, x like t and y is t squared. This is a parameterization. That's the only way? No, of course no. And this parameter vary from negative infinity to positive infinity. It's important specification when you parameterization something, the interval. I forgot to say in the example 1 and example 2, but it's obvious in example 1 and example 2, the parameter vary from 0 to pi. Because this is the closest figure, the closest trajectory. In this case, no, it's open. And the orientation, I suppose, is in this orientation, no? From negative infinity to positive infinity. Okay, don't problem. We continue. First derivative. First derivative t is 1, and derivative t squared is 2t. And second derivative is 0 and is 2. And we compute the famous magnitude, the cross product. We're using cross product, or we're using the formula. The formula, I have the formula here. The formula is, remember, is x prime multiplication y double prime minus x double prime y prime. This is x prime y prime. This is x double prime, and this is y double prime. And the formula is x prime is 1, y double prime is 2. Is 2 minus x double prime is 0. disappear that part. And y prime is 2t, no? But actually, the answer is 2. Divided by the curvature is actual value r prime cross r double prime magnitude divided by magnitude r prime raised to the cubic power, no? Entonces magnitude r prime. So I find the magnitude. Remember the idea for the magnitude r prime is speed. Okay. Velocity, magnitude, es speed. Entonces square root 1 square plus 2t square es square root 1 plus 4t. The famous formula for the curvature is 2 over 1 plus 4t raised to the 3 half. Okay, because the cubic and square root together, okay, it's 3 half. Okay, so suppose now I want to find the curvature at 0. Okay, the point is given at the beginning, no? 0 is here, 0,0. Entonces yo evaluar, plug in, 0 here, es obvio que es 2. The curvature is 2. And the radius curvature is 1 half. And the center of the osculated circle, in my opinion, lie here. What distance? The radius is 1 half. And what direction? In the y direction. Okay, in the y direction. Therefore, the center is located at the point 0, 1 half. Okay, therefore, my osculated circle equation is x squared plus parenthesis y minus 1 half squared equal 1 half squared is 1/4. End story. Osculated circle equation. Compute the curvature of the parabola at t equals 0 and the radius curvature. Any question? Any question? No, professor. Okay, super. I bring another example in 3D. In 3D, we cannot use that formula. No, this formula is only valid for 2D. But okay, we're using the classical cross product, no? Okay, let's do it in 3D. Suppose example number 4, no? It's now. Example number 4 is 3D. Now 3D. Okay, entonces we have a curve que is formed by the intersection two surface. X squared plus y squared equal 1, is surface 1, and z equal x is surface 2. Okay, entonces our curve is the intersection surface 1, intersection surface 2. By the way, for practice, what is the name, or how look like surface 1? What's that? Remember, we are working now in 3D. Don't say circle, because it's no circle. What is that? What is the name? No idea? You need to remember that guy. Cylinder. Es circular cylinder. Remember, it's surface in 3D. C is missing. Therefore, this is circular cylinder along the z-axis. Okay? And what about the second surface? And what about the second surface? What kind of surface you very well know is this surface? Huh? No idea? Huh? Please help me. C equal X. What is the clue? Ese Es el plane. Es obvio que es el plane Restrepo. Es obvio que es el plane. How do you know? Remember the formula for the plane AX plus BY plus C equal D. It's obvious that in this case C is 1 and this guy and this is missing. No, sorry, no. A not 0. It's a mistake. Okay. This C is 1. This A is 1. And this D is 0. Or approximately negative 1, whatever. Entonces, what is the clue to recognize this? When the exponent is 1, it's linear. And when it's linear, it's flat. And TD is flat, the plane. Okay, now parameterization, the curve. Parameterization. Well, we're using the same technique that we studied in the last class. For example, I define, why not, x equals sine. I have the radius 1 of this cylinder. I suppose that y is cosine, or whatever you want in opposite, it's the same. The only thing that changes the orientation. And C is equal to x que sine. End of story. Easy. And the position vector in this curve is sine t, comma, cosine t, comma, sine t. End of story. And this represents the curve, que is the intersection between two surfaces. Super easy or no? Good. Now, in order to find the curvature in different points, for example, you differentiation. Velocity. Derivative is derivative sine is cosine. Derivative cosine is minus sine. And derivative sine is cosine. This is the first derivative. And the second derivative is the acceleration. Is second derivative is minus sine, comma, minus cosine, and minus sine. Is it okay? And I need to find third derivative. Why third derivative? Oh, because maybe we have a torsion. Or no, I don't know. So the third derivative is minus cosine t, sine t, and minus cosine t. Okay. Any chance to Z can also the cosine t? Any chance C? No, because you need to satisfy. No, because there are connection between Z and X. So the equation for the Z is equal to the equation for the X. Copy and paste. That's it. No cosine. Make sense? All right, Annie. Annie, you lost the last class, no? Or you don't understand very well the last class. Okay, let me compute it first of all. The cross product between R prime, cross product. Okay, no problem. Good. Double prime. Let's do in the cross product between R prime and R double prime. So velocity and acceleration. IJK cosine t minus sine t cosine t minus sine t minus cosine t minus sine t. Okay, I want to skip the stupid cross product because I suppose you know. Well, let's do it. I we have this and this is a minus sine cosine minus cosine minus sine. You know the cofactor. When you delete this and this, stay alive, this guy. Minus j, remember the second is always minus j. We have cosine t, okay, you delete this cosine, minus sine, and minus sign and positive sign. Now, wait. This and this. Cosine, cosine, minus sign, minus sign, minus sign. It's minus here, right? Yeah. Yeah. All right, let me see. Yeah. Okay, my paper I put positive. So one stupid sign you screw up. Okay. And K is, delete this and this, is cosine t minus sine t minus sine t minus cosine t. Okay, when you multiply like that, this is sine square, double minus is cosine. This is 1. It's obvious que es 1. Es 1. This answer is 1. This and this is minus cosine sine and positive cosine sine. This is 0. And this is this and this. This is negative negative cosine square, and this is double 3 negative. We have is negative, so it's negative 1. Unbelievable, but the cross product, the vector is r cross product r double prime is equal 1, 0, negative. It's numerical. No, it's constant. It's constant. No. That means when this situation happens, it's because the binomial vector b doesn't change. That is the reason that the curve is in 3D, but it's plana. And the torsion is 0. Okay, let me finish with the curvature. Okay, you compute the absolute value of this. So we get radical 2, no? So 1 square plus 0 square plus negative 1 square radical 2. Okay, now kappa curvature is equal to radical 2 divided by, okay, we come back here to find the magnitude of the velocity. Okay, is square root cosine square t plus minus sine square t plus cosine square t. Okay. This and this together is 1. It's obvious. Because negative sine square plus the sine square plus cosine square is 1. Now the magnitude of the speed formula is square root 1 plus cosine square t. Okay. So my kappa expression is 1 plus cosine square t raised to the 3/2. Yeah, I can compute one by one. Suppose t equals 0. Actually, the intersection for the circular cylinder. Look, the intersection for the circular cylinder and the plane. I am sure que look like elixir, like that. Entonces the elixir you can evaluate in 0, in pi over 2, and pi and 3 pi over 2 in order to determine the different curvature of this curve. Suppose that t equals 0. Suppose that t equals 0. Kappa en 0. Kappa en 0 es, bueno, cosine 0 is 1, 1 plus 1 is 2. So we have radical 2 divided by radical 2 raised to the 3/2, no? Okay, this is 1/2. Therefore, the radius of curvature is 2. Suppose a pi over 2. Pi over 2 is radical 2 over something. Over cosine pi over 2 is 0. 1 plus 0 1, and raised to the any exponent is 1. The radical 2. The curvature is bigger than this, and the radius of curvature is the reciprocal of this, is radical 2 over 2. Okay, and to curvature evaluate in pi. and pi cosine is the same because cosine pi is -1, pero -1 squared positive 1. Entonces es exactly the same as 0. The answer is curvature is 1/2 and radius curvature is 2. There's a repetition because it's cyclical. And finally, in 3 pi over 2 is similar to the pi over 2. It's radical 2 and the radius curvature is radical 2 over 2. Okay. Well, the rest is we can do that. The graph this and GeoGebra, but I don't skip that. Okay. Suppose by curiosity. Let's compute it by curiosity. Tangent, unit tangent vector, unit tangent vector. Unit tangent vector. There are many ways to compute. One, the fantastic way is the velocity divided by speed. This is the formula. Evaluate specifical in one point. No? Suppose, well, in general, the unit tangent vector expression is, look here, this vector divided by this expression. Entonces es cosine t, coma, minus sin t, coma, cosine t, divided by square root 1 plus cosine squared. This is a scalar function, and you put if you want inside component by component, if you want, or you put like a common factor outside. It doesn't matter. Suppose I want to evaluate, suppose the unit tangent vector at pi over 2. Entonces cosine pi over 2 is 0, sin pi over 2 is 1, cosine pi over 2 is 0, divided by cosine square pi over 2 is 0, and the unit vector es obvio que es 0, -1, 0. That's it. Enough. Okay. Okay, guys. This is no super complicated problem, no, but the complication is the algebra. This is the algebra. The algebra is our nightmare. Okay, entonces si you make a mistake in one stupid sign, this is the mathematics. Mathematics is hard because any stupid mistake screw up everything. Okay, the last application, okay, I want to discuss it with you of the normal vector, tangent, unit tangent vector, unit normal vector is the decomposition of the acceleration. For example, decomposition of the acceleration. What is that? Suppose that we have one trajectory. Suppose that I pick one point here. In this point, we have a velocity vector, okay, always is like that. And we have acceleration vector, okay, I suppose que es this. Suppose. I have no idea exactly the location, but see the curve rotate like that. In my mind, it's obvious that the acceleration is in this direction. But let me try to do not too long vector. Suppose like that. Accelerate. Suppose, hypothetical. Well, the goal is break it down this in two components. One component is the tangent component for the acceleration, and another component is the normal component of the acceleration. normal component of the acceleration. Because I suppose that the normal vector is located here. The uninormal vector. And this is the unitangent vector. The unitangent vector is in the same direction of the velocity. So basically, the thing that this is, the goal is break it down, decomposition, acceleration, into components. Tangent acceleration plus normal acceleration. I suppose that we have no binormal acceleration because the trajectory is in one plane. Okay, it's 2D problem. So it's 3D, so we need to include another extra component binomial acceleration, but no. We don't want to complicate, but it's the same idea. Okay, so we're using the projection that you know. We have, remember, we have two projections. We have the horizontal projection and the vertical projection. And the horizontal projection, we apply dot product. And the vertical projection, you apply cross product. You know very well this idea. So for example, in order to find the magnitude of the tangent, well, the only thing you should do is find the horizontal projection and the direction of the velocity. Entonces, you perform the dot product between velocity, dot product acceleration, and divided by the unit vector. So the magnitude, basically, the division B divided by magnitude is this guy is a tangent, unit tangent vector. Of course, this is a scalar. It's a scalar. So in order to find actually the vector, well, the only thing you should do is multiplication, the magnitude, multiplication by unit tangent vector. Likewise, so you try to find the component that is orthogonal, okay, you using cross product. So this normal is cross product who? Cross product velocity and acceleration. Of course, magnitude of this divided by the magnitude of velocity. And this give me this component, que es scalar. In order to find the component normal, you multiplication the magnitude of this, que you compute after. But for cross product and projection, vertical projection, and multiplication by normal vector. Okay, let's do an example of the decomposition acceleration in two components, tangent and normal. This is classical in physics. When you study circular motion, and they in physics call a little bit different. This is call it radial. Okay, by the way, this is centripetal acceleration, and this is tangential acceleration. Okay, let's do an example. Suppose circular motion, not exactly circular motion. Suppose it's given the vector value function que represent the position vector, que es cosine t, sine t, and t. And remember, this curve look like helix, like that. I encourage you to go to GeoGebra and put this vector value function. I suppose you know how you put it in GeoGebra. Okay, and you see the helix. And your specification, I want to heal it between 0 and maybe 8 pi, because I want to see several periods of the healing. Okay, you find velocity. Velocity is the first derivative. Okay, minus sine t, comma, cosine t, comma 1, acceleration. Acceleration is minus cosine t, minus sine t, and 0. Now you want to find the component, tangent component, or tangent component of the acceleration, like a dot product b dot a divided by magnitude of b. Okay, multiplication, who? Multiplication, this and this, this and this, and this and this. So I have minus sign, and minus cosine, positive sign, cosine, cosine, cosine t, sine t, and this is minus cosine t, sine t, no? Wow, it's 0, divided by something. Divided by, I forgot to compute the magnitude of velocity. That the speed formula is square root, well, let me erase that part of the helix. Okay, square root what? Negative sine square, sine t square, plus cosine square t plus 1 square. This is 1. And 1 plus 1 is 2, es radical 2. Divided by radical 2, pero es 0, wow. Entonces, en this case, I prove mathematically que in this motion, the helix, we have no tangent acceleration. Wow. Because circular motion. Y I suppose que the speed is constant. Si the speed is constant, when you differentiate the speed, so dvdt, it's 0. And this is the same result. Guys, we have always two possibilities. Using calculus, derivative, or geometry, dot product, cross product. Okay, let me try to do the other component. The other component is B cross A. So the normal, no? The normal is B cross A. Okay, B cross A. Magnitude. Okay, now let's do it first. B cross A alone. B cross A. B cross A. Okay, is IJK. And the component for the B is minus sine t, cosine t, 1, minus cosine t, minus sine t, and 0. When you compute that, I will skip that part, is sine t minus cosine t, and 1. Now, if you compute the magnitude of this, I did before similar, but the only thing that changes the sign is radical 2. Es radical 2. Okay, entonces the component of the normal acceleration is magnitude B cross A divided by magnitude B. And the magnitude B cross A I found is radical 2. And magnitude B is radical 2 also. I computed before. Look at that here. Entonces the component of the normal acceleration is 1. Okay, entonces the normal acceleration is 1. If you want, for example, compute the unit tangent vector. Unit tangent vector is velocity divided by magnitude velocity. Okay, entonces es the vector velocity, que es this vector, divided by this, que es radical 2. Entonces es minus sine t over radical 2, comma, cosine t over radical 2. If you want the radical 2, you put inside component by component divide, or no? 1 over radical 2. This is the tangent vector. And the normal vector, there are many ways. In this case, I don't know, in my paper, I prefer calculus. You divide the unit tangent vector divided by magnitude of this. So basically, the answer is, well, the derivative of the tangent vector is differentiate this, no? When you differentiate this, you have minus cosine t over radical 2, comma, derivative sine derivative cosine is sine over radical 2, comma 0. Because derivative constant is 0, no? Entonces, when you divide by magnitude this, que by the way, the magnitude of this is radical 2 over 2, or 1 over radical 2, que es the same. When you divide, the unit tangent vector is now minus cosine t, comma, minus sine t, comma 0. Well, entonces, what is the final answer, Professor? Well, the final answer is acceleration contain two components. Acceleration tangent multiplication by tangent vector plus acceleration normal multiplication by normal vector. But we discover in the middle of the process that the component tangent is 0. This part is 0. This part is gone. And acceleration is this component que es 1. Look. Multiplication by normal vector. But the normal vector is, I have here, no? Minus cosine t, comma, minus sine t, comma 0. Okay. And this is not new. Coño. Because we discover in the middle of the process the acceleration expression. Look. Okay, I bring this elementary example to illustrate the possibility to using the TNB frame in kinematic. Wow, the time flies. Guys, I want to start the review for the test. Okay, so we spent today 10 minutes only we have. And Wednesday. I don't know if I have time or no. Okay. I bring one proposal. Okay, suppose que I totally agree. I extending a little bit the due date for the test, number 1, to the June 2nd. No May 28. Sino June 2nd. June 2nd, I need to change in the MyMATLAB. Remember, June 2nd is the last day. Test on paper and test online. I want to change. No, I don't change, but I want to change when I finish this June 2nd. Okay? Okay. I suppose that everyone received the study guide for the test number 1 on paper. Yes or no? Let's do in the question 1. Let's do in the question 1. Question 1 say, find the length of each vector and the angle in between these. Those two vectors given, u vector, que es the vector radical 2, radical 3, radical 6. Semicolon, and the vector b, que es the vector 1, 0, 0. I need to find the magnitude of this. Super easy, square root, any component square is 2 plus 3 plus 6. This is 11. Approximately, in decimal approximation, 3.32. Not necessary this. You leave it like that, perfect. And the vector b es obvio que 1, no? Because the only component que is stay alive is the first component. 1 squared plus 0 squared plus 0 squared. In order to find the angle in between the vector, you perform the dot product. U dot product b. Okay, let's do it. Entonces, es obvio que yo multiply component by component, ¿no? Es obvio que es the dot product radical 2, radical 3, radical 6, dot product 1, 0, 0 es radical 2, ¿no? Es radical 2. But this answer is equal. The other formula que you know es que A dot product B is equal magnitude A que I have, magnitude B I have, cosine theta. And my goal is find the cosine theta. Entonces es easy because the magnitude is radical 11, and the other magnitude is 1, no? Cosine theta. Therefore, theta is equal to the cosine inverse of radical 2 over radical 11. Put in the calculator, and the answer in degree is 64.76 degrees. This is super easy, guys. In the test, I don't want to put complicated example. Easy example. Any question in the question number 1? No? Any question? Come on. I am happy. Okay, June. No, remember, I'll take the due date to the, but you have to work, guy. Suppose that you are doing the test on paper good, and you are doing nothing online. And to say you don't pass this class because it's 50%. Okay. So online is important. Okay, now let's do in the question number 2. Question number 2 in the review package say find the area of the triangle whose vertex is. So we have 3 points, P1, 0,0 the origin, very well. You have P2. It's 1,0, and we have P3. Okay, it's 1,4, 1,1,4. Okay, you can plot the point if you want, but no, not necessary. So you know, okay, this is the tricky part. You know, get the cross product. So you perform, for example, P2, P1, or P1, P2, no? P1, P2, no? Vector. Now you take like a pivot, like a reference P1, okay, the origin. You determine the vector between 2 points, no? Okay. By the way, is 1, 1, 0, no? Because it's 1 minus 0, 1 minus 0, 0 minus 0, no? And the second vector is the vector P1, P3, no? Vector 1, 1, 4. This is no vector. This is a point, parenthesis. This is a vector, angular bracket. And when you perform the cross product P1, P2, cross product P1, P3, something that when you perform the cross product, the interpretation cross product is the area, the area of the parallelogram, not the triangle. So suppose que you have 2 vectors. Entonces the actual value, of course, of the cross product give me the area of the triangle. But they want not this. They want the triangle like that. Well, it's easy because when you compute this and the answer is 20, the area is 10. It's 1/2. This basically they want this. Don't confuse it with this. So now you perform the cross product. The cross product is, let me try here, IJK. 1, 1, 0. This guy. 1, 1, 4. Okay, good. And the answer is, I skip the step of this. The answer is 4, negative 4, 0. You want to find the magnitude of this. Magnitude of this vector. Magnitude actual value is square root 4 square plus minus 4 square plus 0 square. Is square root 32. We break it down. 32 is like a 2 and 16. Square root 16 is 4. That's 4 radical 2. 4 radical 2 is the area of the parallelogram. Parallelogram. You want to find the area. It's the area of the parallelogram. You want to find the area of the triangle. It's 1/2 this. It's 2 radical 2. End the story. You want to put it in decimal approximation, but this is totally optional. 2.8 to 8. End the story. Clear or confusing? We have time to one more or no? All clear. Okay, Annette. All clear. Let's do one more, and that's it. Let's do one more, and that's it. Suppose number 3 basically is find the vector equation, parametric equation, and symmetric equation, and the line through the point 5,3 and 1, okay, doing quickly. Okay, I do the review super quickly, because I suppose you know very well this. Okay, number 3. They are easy questions and they are complicated, of course, and long, stupid questions, but it's okay. You have time. Do you want I send today the test on paper, and you start doing that, or no? Yeah, as soon as possible, no? Yeah, Ricardo is of course, give me. I want to send today the test. That we have 2 points, A and B, and the question 3. Okay, 1, 2, and 4. And you find, okay, remember the 2 pieces of information. Okay, you need to express the equation of the line. Professor, the test on paper. 10 questions, only 10. The online 20 question, online 20, on paper 10. The difference is on paper you need to show me the word in detail, okay? Both the same do the, yeah, June 2nd, yes, Annette. Okay, Annette, you have a lot of work, I know. I suppose for the second test, you take advantage, you manage your time much better. In general, some people almost finish everything, but other people don't start. Okay, so you need to find the equation for the line in 3D. We need 1 point, I suppose que say, bueno, 5 to 3, and direction vector. So you find direction vector, suppose direction vector. Direction vector is, for example, you subtracting the component. I suppose, guys, when you see this order A, B, from A to B, it's because the vector look like that. This is the tail, que say, this is the arrow, que B, no? So you subtract 1 minus 5, negative 4, comma, 2 minus 2 is 0, comma, 4 minus 3 is 1. This is direction vector. And the equation in vectorial form is the vector que you suppose que 5 to 3, you convert this point to the position vector, the scalar t, and the direction vector que is negative 4, 0, 1. Now this is no, that is perfect. However, some people prefer doing it that way. 5 minus 4t, comma, 2 plus 0t, not t, because the direction vector here is 0, and 3 plus 1t. And the parametric equation for this is x equal 5 minus 4t, is my first equation. Y is just 2 because we have no t. Okay, but sometimes happens, sometimes no. And c is 3 plus t. Okay, this is a parametric equation. By the way, t vary from negative infinity to positive infinity because it's a line in both infinity in both directions. And the symmetric equation is too easy. You isolate the t, but you isolate the t here and here. We have no t here. Okay. When you isolate t here, you have x minus 5 divided by negative 4 is equal to t, no? And here is c minus 3. Leave it like that. Oh, I don't know. See, it's perfect. It's perfect. It's perfect. You want to change the sign here, 5 minus x over 4 is equal to c minus 3. Remember, 3 different ways to express the same idea. Vector equation, parametric equation, and symmetric equation. End the story. Okay, too much. We continue Wednesday. We continue Wednesday. We continue Wednesday. Okay. Okay, thank you. It's a pleasure anytime. Entonces, today I want to send with the email for the video. I send also the test, and you start working. Okay. Okay. Have a nice day for everyone. Stop recording.